Hey superheroes, this is Alexander Bear, and I'd like to welcome you to the Modern Day Superhero Show.
What is your mission? What's your purpose here? Why do I get out of bed every day?
What I really wanted to do was to change the face of medicine one patient at a time.
That moment I connected that dot, that peace would come from sharing my own truth, sharing my own journey. That's when, the shift really happened for me.
The Modern Day Superhero Show.
Welcome everyone to episode number 3 of the Modern Day Superhero Show. Today I sat down with Dr. Dominic D'Agostino, who's a researcher at the University of South Florida that develops nutrition-based therapies for the metabolic management of neurological diseases and cancer. We discuss formulating a proper ketogenic diet, the truths of adaptation to ketogenic diets in regards to sports performance, timing when to eat before and after exercise, the safety and efficacy of ketone supplements, the importance of training your body for metabolic flexibility and how to do that, research that Dr. D'Agostino is currently working on using nutritional therapies for cancer treatment, along with tips and tricks for finding and maintaining motivation, as well as for finding purpose in life. If you've never heard of the ketogenic diet, I recommend you starting off by going to moderndaysuperhero.com/keto start guide to get useful information on what the ketogenic diet is and more resources you can read to find out even more about the ketogenic diet. So without further ado, I'd like to welcome you to episode number 3. Hey everyone, I'm sitting here with Dr. Dominic D'Agostino at the University of South Florida in Tampa. Dom, it's a real pleasure to have you on the show today. I know you've been featured on Tim Ferriss's show, Dave Asprey, Bulletproof Radio, Dr. Rhonda Patrick. I even first heard about you a couple years ago through Dr. Mercola's website. So you've talked to a lot of the major health giants, major podcasters. So for you to come on the show, I sincerely appreciate it.
Thanks for having me, Alex. I appreciate being here. Appreciate you highlighting kind of our lab and what we're doing. And it's always important for me to get our information out there on what we're doing. And you're really helping with that. And I appreciate it.
Thank you. So would you like to introduce yourself, just
Sure.
what you're doing now at the USF and
Okay.
all the associations you have and whatnot?
Yeah, I am an associate professor at University of South Florida, Morsani College of Medicine, the Department of Molecular Pharmacology and Physiology. And I'm also a research scientist at the Institute for Human and Machine Cognition, which is located in Pensacola and also Ocala, Florida. And the sort of main thrust of what we do is developing what we call metabolic-based therapies or nutritional therapies. Some of them are to enhance warfighter performance, resilience, capabilities. And in addition to that, we develop these therapies for the metabolic management of neurological diseases and cancer.
Yeah, thank you for sharing that. It's wonderful work, and it's great that you're sharing it on in so many different formats, podcasts, blogs, so that people can actually become aware of this type of research and really affect change in their lives. So, thank you. I just want to start off with just getting to know you. And it is kind of awkward because, like I said, I've listened to a lot of different podcasts, so I have a good idea of, I know you're from New Jersey, is that correct?
Yeah.
And
yeah.
One podcast,
Born and raised.
Yeah, I think Fit to Fat to Fit is, you grew up on a farm, and
yeah.
I know all these things, but it is, and I do encourage people, I'll put some show notes to go back and listen to some of these podcasts that are on your website. We'll get to that later, but is there anything in particular that you remember from your childhood or just kind of going through life that really sparked your interest in exercise or nutrition, and then your interest in ketogenic diet research?
Yeah, well, if I go back, I think my interest really got stimulated when I started. It's a combination of playing sports, for me football, and my brother was always, very good in athletics, and I wanted to be just like my big brother. And he was really strong, had the highest bench press in the high school, and kind of an all-around athlete. And I just wanted to be like my brother, and at the same time, wanted to be big and strong. Arnold Schwarzenegger was a big inspiration to me. I watched all his movies over and over again. So I would say that was happening at the age of 12, 13, 14. I read a book called The Education of a Bodybuilder, and that was by Arnold Schwarzenegger, and that really inspired me. And it was at the same time I was getting interested in biology. And I took like what was called a college biology class in high school, and then an honors biology course, and gross anatomy, and studying, physiology and deeper levels of biology got me interested in understanding human physiology and how I could kind of leverage nutrition to enhance performance, and I think it really started to get of high interest to me in the ages of 14, 15, and 16, and then I didn't necessarily apply it effectively until about the age of 17, 18, and 19, where I started to grow in size and strength, and for football mostly.
Yeah.
So, and at the same time, while this was happening, I was really interested in the outdoors. I had dirt bikes, ATVs, even snowmobiles up there in New Jersey, and I was working on a farm and pretty much doing heavy manual labor, like baling hay and things like that, through the entire period, through high school and even through the early part of college. So I was always kind of an outdoor physical person, and strength was always like really important to me. So that kind of ties into nutrition.
Yeah.
So I guess it was around the latter part of high school that I began looking into nutrition science programs, and one was at Rutgers University. And when I did start my undergrad training or schooling in nutrition science, I became a little bit disenchanted with the nutrition science program because it didn't leave a whole lot of options for what I really wanted to do.
Right.
And even at the time, I was interested in like a high protein, low carb diets because it was being talked about in the magazines even over 20 years ago. Yeah. And I was encouraged by my undergrad mentor to double major in biology too. I think so. It was the end of the first year. I said, okay, well, maybe I'll make biology my main track and have nutrition science as kind of like my secondary major, just because the options for a career in nutrition were not that great, like working for Nabisco or something, formulating cereals and things like that. I looked into like 3 or 4 different jobs and just kind of followed up with some of the potential jobs that other people that graduated from Rutgers were doing. And I realized, well, you know what? I think I want to go to medical school, and so I started preparing for that by taking biology and also doing undergraduate research, which I would encourage any undergrads out there to go into a lab that's doing something that you're really passionate and interested about, and see if you can offer to help in that lab. Oftentimes, the investigator may not be funded to where they can pay an undergrad research assistant, but I started just doing it for experience to look good on my medical school application. Yeah. And as I started liking it more, I started putting in more hours. So my principal investigator at the time felt that, hey, well, I should be getting paid. So I ended up getting a decent salary, like hourly salary, working as an undergrad in the lab. And then my undergrad research ultimately became my PhD dissertation project. So in a way, I got like a head start because I was able to kind of parlay that undergrad research experience into a doctoral dissertation. Yeah,
and what was that on?
I studied, as an undergrad, I looked at phenotyping, sort of characterizing, I would say, the neurons in an area of the brainstem called the rostral ventral lateral medulla. And the RVLM, it's known for, is a group of brain cells that control cardiorespiratory activity, so the neural control of autonomic regulation. And these neurons have a distinct neurotransmitter phenotype. So my undergraduate project was to use immunohistochemistry and immunocytochemistry to identify the phenotype of these neurons, what neurotransmitters they use, and ultimately so characterize their connections. So what this area of the brain connects to such and such an area of the brain, and also this foundational research led to characterizing their electrophysiological activity. So I started doing that towards my undergrad, but patch clamp electrophysiology is very hard to do. So my last semester as an undergrad and then the first semester in graduate school, I took a class that was essentially electrophysiology patch clamping. And then my transition from undergrad to graduate school was basically going from staining cells and then looking at them in a microscope to using physiological techniques to record their electrical potentials to characterize their function. And in characterizing their function, my PhD research was to look at an oxygen sensing mechanism that they have. So the brain stem can sense levels of oxygen in the brain, and under extreme conditions it can activate an autoresuscitory mechanism that we know as gasping. So and the etiology of gasping has been implicated in SIDS. So I was kind of studying a brainstem mechanism of chemosensitivity, we call that. So it could sense CO2 or oxygen. So I was looking at oxygen, and that essentially became my PhD dissertation. Was kind of an in-depth analysis of those neurons.
Thank you for sharing that. And that is inspiring to younger folks listening about the undergraduate research. I know at University of South Florida I also did some undergraduate research and aware of how many opportunities there are. And unfortunately, I actually didn't know about your work until recently, so it's been great to get in with you on that. But if you don't mind, just for the purpose of this, maybe we can talk about some of the ketogenic diet stuff. I was just curious. I listened to some podcast of your podcast, and I was just curious what you eat on a day-to-day basis. I've heard kind of different things. Maybe you vary it with whether you're exercising, not exercising. So what is it that someone who's got all this knowledge in the ketogenic diet, spent many years researching it, what is it that you eat on a day-to-day basis?
Well, I don't try to be too rigid with my diet, and I try to keep it somewhat flexible, but from an outsider looking in, it probably looks really rigid. But over the years, it seems extremely flexible to me. And it will depend, as you mentioned, on my activity level, if I'm traveling, if I'm home, like I was today. Essentially, as you know, I like to eat a macronutrient profile that kind of keeps my body into nutritional ketosis. So that's basically a high fat, always more than 50% of my calories from fat, usually around 70 to 75%. Fat, moderate protein, like anywhere between 20 to 30% protein, and then a minimal amount of carbohydrates in the form of green leafy vegetables, asparagus, broccoli, cauliflower, that sort of thing. So it's going to vary day to day. So I'll give an example. Last week I was traveling, and I brought with me sardines and oysters, and we were staying in Colorado, in Durango, and we were doing a lot of hiking and horseback riding, outdoor stuff. And I ate a little bit more than normal, and I woke up. That's right. We had like a little apartment thingy, so we had a stove, and I kind of stuck with my normal, but I didn't fill up too much on fiber. So if I'm going to be active during the day, instead of having like a lot of like vegetables, I had very minimal vegetables in the morning. I think I had like 4 scrambled eggs and a can of sardines on one day, and then but in this morning I had about 3/4 of a pound of fatty ground beef, a fatty section of grass-fed ground beef, and I had a little bit of salad left over from the day before. But it's going to vary, and tomorrow I have a really early flight out. So tomorrow my eating pattern will be intermittent fasting, so I'm not going to I typically, if I have to wake up really early, I'm just not hungry at all.
Right.
And I will, I have a number of flights to get to my destination, and I will bring some MCT powder and maybe a packet of exogenous ketone formula, which is like ketone salts mixed with MCT with me.
Yeah.
If I do get a little bit hungry, but typically I don't, and I'll bring that with me. You know, put the MCT powder in my coffee or drink the ketone shake, you know, halfway to my destination, and we won't get there till late at night. So it does vary. I like to intermittent fast about once or twice a week, and that usually happens because I have to wake up really early and I just don't have an appetite in the morning. But on an ideal day where I'm not really under a lot of other obligations, I will typically, you know, just have coffee in the morning and work for a little bit, and then I will eat breakfast, usually an hour or two after that, and just kind of take my time, and it'll be similar to the breakfast I described.
Yeah. And something I found you had said before, I wonder if you can expand on this a little bit. Well, two things. The first one, when you're exercising, most people have it in their mindset, you know, you want to eat something before you exercise, you want to eat something after you exercise. But from what I was listening, when I was listening to these podcasts, it sounded like sometimes you'd go and fasted, or maybe you had some MCT oil beforehand, and maybe not even eat after a workout. And I guess it's probably not good to assume, but you probably do deadlifts and more functional compound exercises. Mm-hmm. So can you speak on that a little bit?
Yeah, I think it's important not to go into, you know, a difficult exercise routine in an underfed state. Yeah. But you could keep in mind that you could be fasted throughout the day and exercise in late afternoon or evening. But if you've eaten sufficiently the day before, which sometimes I will try to do if I know I have a brutal workout on Monday, I'll kind of overeat on Sunday and undereat, fast or undereat on Monday, and then train. So, you know, think about like what you're eating today for your workout tomorrow. Okay, I think in terms of that. And I do feel best going into my workouts a little bit hungry. So if you've eaten a big meal, I mean, some guys like to eat a big meal and then go train.
Yeah.
I have a really close friend of mine, Lane Norton, is big into, not so much into low carb nutrition, but I remember when we first trained together, I think we were in Washington, D.C., and he got me, and it's like, we were on the way to the gym, we stopped at like a Mexican place, and he ate like a bunch of food on the way to the gym. And I was like, wow, this is different. And I forget, I mean, I think just to be polite, I had like a little bit of meal or coffee or something like that. Yeah. And for me, I feel that if my body's trying to digest, it's diverting blood flow to digestion and assimilation, and I just don't feel optimal. But some people believe, you know, that food has an anabolic effect, you know, if you go and work out, that you have those nutrients are being pushed into the muscle. So I've done it both ways over the years, but I do like to go into my training a little bit hungry and kind of semi-fasted. And if my workouts are usually really, really short, like on the order of 5 to like 15 minutes, and sometimes a longer one will be 30 minutes. And if I really kind of have a lot of time on the weekends, I'll do an hour of kind of a circuit training. Yeah. But generally I like to give my body like an hour or so of recovery just so my physiology gets back to normal before I start putting food in my system again. Right. Because your stomach and your digestive system is just not kind of in tune to be taking on a large meal after your sympathetic nervous system and everything is activated. So I like to bring my body down, and I'll actually look at my Fitbit to make sure, you know, my heart rate is down to, like right now it's like 68. So I'll wait after I work out, it's elevated well over 100, and even without cardiovascular. And then even 30 minutes after, it's still like in the 80s to 90s. So I like to wait about an hour or more, and then I know my sympathetic nervous system is not dominant, and I tend to get, you know, I don't feel like I digest the food great if I eat a big meal immediately after I work out, or immediately before. So
thank you for answering that. That's I feel like that's a huge I wouldn't say misconception, but a lot of people standardly would think of this diet as really important to eat, at least, you know, from my understanding, it's really important to eat as soon as you can afterwards. You see that with, you know, there's all these protein shakes, whey protein, you want to get that down as soon as you can, but it's fascinating that it's not the case. And So do you want to speak on that a little bit?
So, well, I think small amounts of things like medium chain triglycerides or branched chain amino acids immediately before or intra-workout can be helpful, especially in those people who are doing long workouts. Like, I do talk to a lot of elite level endurance athletes that their training, when they say, so going into their training, they're going into a 4 or 6 hour session.
Right.
So that's completely different than what I do, which could be a short, literally like 4 minutes, I think, my workout yesterday.
Yeah.
So that's completely different. And it would involve intra-workout nutrition. And I think the best way to do that is, if you're going to do an ultra marathon, you might want to throw in some slow carbs during the actual event, but ideally you want to do some branched chain amino acids and some kind of ketogenic powder, like pre-workout, and then in the middle of, if you have a 6 hour bout, in the middle of that.
Okay. And something else that was interesting in terms of this diet, you said, I think it was about 2,500 calories a day. Is that still the case? Like on a normal day or something?
Yeah, it varies, but if I'm doing a lot of outdoor activity related stuff, it could be as much as 3,500 calories, and I could go from 1,500 calories one day to 4,000 the next. So I do think it's good to keep your body metabolically flexible by varying. For me, it's not so much the composition of the diet, but the types of foods that are in the diet, because I think that aids in the diversity of the gut microbiome. Yeah. If you throw in a variety of different vegetables and different fibrous carbohydrate sources, and even protein and fat sources. So it does vary depending on my activity level and things. But generally speaking, it's a pretty big range, but 2,000 to 4,000 calories per day. But sometimes when I do a day of intermittent fasting, it could be 1,000 or 1,500 calories.
Yeah. You mentioned this, looking over at Dr. Rogers. This metabolic flexibility, is that just in terms of the calories you're eating, or are there times you eat higher levels of carbohydrates that might actually kick you out of ketosis? Is that something that you ever do? Is that something that's beneficial to people? Or
if I eat carbohydrates, I don't do it intentionally for any kind of performance advantage. I will do it as a result of traveling to locations and experiencing the foods of different cultures, or maybe not to be impolite if food's offered to me. But generally speaking, I'm not using the diet to manage any kind of, metabolic problem or disorder or anything like that. So I'm pretty flexible. I just generally like to eat a ketogenic diet regimen because I have more energy and it sustains me, and I honestly like the food better. So if I do eat outside of the ketogenic diet, it'll be things like maybe popcorn at the movies, or we have some fruit trees in our yard and I might eat a mango here and there, or dark chocolate, kind of things like that. But generally speaking, I kind of stick to, maybe, I think on our grocery list we have about 20 different foods. And then sometimes I'll have variations of those foods. So if I'm buying fish every week, I'll switch it from trout to salmon to some other kind of fish, or shellfish or whatever. Yeah. So I like to consciously rotate the kind of foods that I'm eating. And if I'm traveling to different countries, I do make it a priority to try the traditional foods of that country, whether it be we're in Philippines and Cambodia and Malaysia and Hungary, and when I was in Italy and Naples, I had to have a little bit of pizza. So, so I just don't go crazy with it.
Right.
So.
Yeah. So on the topic of keto adaptation, from Bullock and Finney, they mention it's about 2 weeks to maybe 2 months. I've heard you say it could be longer.
Yeah.
Is there any way that you're aware of that can help catalyze that process, or just lessen the effects of this adaptation process, which for some people it's different for everyone, but you may feel fatigued or you have some brain fog or something like that. So is there any way to just perhaps use exogenous ketones or use something or just make it so the adverse effects may be lessened a little bit for someone who wants to start this kind of diet?
Yeah, I get many questions about this every single day, and I think first and foremost, I say everybody is different,
right.
And I would say that someone who's very athletic typically can adapt to a ketogenic diet regimen fairly quickly, especially people that are like moderately, but not like super athletes. And then if we have these ultra athletes that are extremely carb dependent, they may have a problem because they're so in tune with their body that they are pushing their bodies so hard, and their bodies have fine-tuned to that fuel source, which is carbohydrates and sugar. And it may be, so in the athletes that I've talked to, elite level athletes, they say it takes about a half of a year for their times to come back up to normal and then surpass their times. So the elite level, what is considered low carb athletes, like I know Jeff Volek, in his study, he had athletes that were adapted for over a year, and I think that's really the way to do it. You don't want to take an athlete that's been adapted for 3 or 4 months, because I don't even think that's enough, because you have acute adaptations that happen. Obviously, if you take a metabolomic profile of their blood or tissue, you're going to see some changes in there. But most importantly is that there's epigenetic effects. So the metabolites are epigenetic regulators in that they're instructing the nuclear genome to upregulate the production of ketolytic enzymes, so enzymes that can break down ketones for energy, proteins that are associated with the transport of ketones, like the monocarboxylic acid transporter 1, 2, 3, and 4. And their tissue localization is going to vary between muscle, between brain, and things like that. So various tissues have even their own keto-adaptive rates. Like the kidney is kind of dependent on glucose more than other organs. The brain is very sensitive to the level of glucose, and a ketogenic diet will signal a mild glucose withdrawal in the brain, and you might go through what I would call like a dysphoria and kind of initially until your blood ketones get elevated sufficiently, and then you've upregulated the transporters to ensure sufficient fuel flow to the brain. And one way to fill in that gap is to use ketogenic food products like medium chain triglyceride oil. You got brain octane, you have standard MCTs that you can buy pretty much at any nutrition center. You have Quest MCT oil powder, which is great. And then you also have on the market, introduced recently, is the exogenous ketone formulas that literally have ketones formulated as a mineral salt. So sodium, potassium, calcium, and magnesium combined with beta-hydroxybutyrate and formed into a powder, and that powder is mixed in many cases with an MCT-based powder as a carrier. And when you consume that, and even if someone's on a carbohydrate-based diet, if they consume the product and you look at their blood 30 minutes later, it looks like they're on at least a modified Atkins diet or a modified ketogenic diet. Their ketone levels may not be really high like you'd get with a clinical, what's known as a classic ketogenic diet, but it does boost the ketone levels to millimolar concentrations, or about to 1 millimolar, and that's a significant amount of energy in your blood. If you have a millimolar concentration of something in your blood, that's supplying a significant amount of energy to ensure that the organ, my interest is really the brain, is getting a sufficient fuel flow. It was last week, I believe, that we published in the journal Cell Metabolism, a fairly high impact journal. We published a preview article on kind of describing the use of ketone esters in elite athletes. And it was kind of a follow-up article to the Cox et al. Paper that was a group project between NIH and Oxford University, where they did essentially 5 different experiments in elite athletes with ketone esters specifically.
Right.
They're eating a normal diet and they were fed ketone esters, and So the three takeaways, I would say, was that the ketone esters, when consumed acutely, shifted metabolism to reduce glycolysis and shifted it more towards ketone metabolism, obviously, and also enhanced muscle triglyceride or muscle fat oxidation. So it literally, you could within 30 minutes shifts a person's metabolic physiology by having them consume a ketone ester, which is a powerful concentration of a ketone body. Most significantly from an athletic performance point of view, was that lactate levels were 50% reduced in athletes, and they did a battery of different tests. And I guess the third thing would be that their time trial improved significantly. Because they're already elite athletes, it's hard to improve upon, someone that's already metabolically fine-tuned.
Right.
But I think it was on the order of almost 2%, or right about 2, maybe 3% in some athletes. So at the elite level, that 2% is pretty significant. I did have some critiques of it. I think they compared that to just a carbohydrate-based only formula, and the formula that they were testing, they actually included, it was ketones and carbohydrates together.
Yeah.
So this particular lab at NIH and at Oxford, they developed the ketone esters not essentially as a replacement for the ketogenic diet, where so they believe that the ketogenic diet is far from ideal and has a lot of problems. And I, on the other hand, I believe that the ketogenic diet eating strategy is kind of ideal for the warfighter and for the athlete, and that eating a ketogenic diet regimen can help to transition your body into a fat-burning, ketone-burning machine, and that your adaptation to enhancing fat oxidation will be, and using ketones will be advantageous when you take a ketone supplement, because your body's already used to burning ketones, instead of just taking it acutely before a major event. If your body's already fine-tuned and adapted to using fats and ketones for fuel with a ketogenic diet. And that's really the next study that we want to do. We want to take athletes, not just elite level athletes, but elite level athletes adapted to a ketogenic diet, and then dose them up high with a ketone ester and see and really try to push their performance. And I think ultimately, from an endurance perspective, these athletes can really push the limits.
Yeah. From my understanding, ketone esters aren't really commercially available, but ketone salts are. So comparing the two, I've heard that obviously ketone esters are higher concentrated and they're going to be more effective. But if someone's listening to this and they're saying they hear what you're saying and think perhaps I can use ketone salts to reduce lactic acid production by 50% or increase my performance, is that true or no?
I think so. Ketone salts are evolving to the point now. Our lab is at the cusp of kind of formulating things that could be approaching the potency of a ketone ester.
Wow.
So right now, the ketone ester that was tested in that study was a monoester beta-hydroxybutyrate, and which basically means you have a molecule and then a ketone attached to that molecule with an ester bond, and that's one ketone. And we are working with a diester, which would be two ketones attached to a molecule. The molecule would be of interest is 1,3-butanediol, which it breaks down in the liver completely to beta-hydroxybutyrate. And then if you take that molecule and then you do a transesterification and add beta-hydroxybutyrate to it or acetoacetate to it, it becomes a very potent ketogenic molecule. And we're working with that, and we're also working on formulating ketone salts. So there's a balance of electrolytes, a balance of minerals. You have monovalent and divalent cations, which could be, sodium, potassium, calcium, magnesium are the main ones. But there's also amino acids that you can formulate ketones with. And we're interested in creating a ketone salt, formula that's balanced in a way, and also mixed with like an MCT preparation that's an effective carrier and that can delay absorption a little bit and extend the levels in the blood for longer periods of time. So we think that these ketone salts will approach and maybe exceed, the potential of ketone esters, because even with ketone esters, they get kind of hydrolyzed in the gut, so they're sort of limited in certain ways. And also 1,3-butanediol at higher levels can start to produce a mild narcotic effect that I would think could actually be counterproductive. We haven't proven that yet, so we are, right now what we're doing is we have about a dozen different ketogenic agents and formulas of those agents, and we're testing them in different animal models on a variety of different things, including exercise performance. And out of that data, we should be able to key in on the key formulas that are enhancing physical performance the most, and then we will move those key formulas to human exercise studies. So we're at that stage now.
That's amazing.
It's kind of fun, yeah. Because coming back, I am in a pharmacology department, remember, but it's also physiology. I do appreciate kind of drug research, and actually we do a fair amount of drug research, metabolic-based drug research. But I would say most of what I do, I've fallen back on my nutrition background, and instead of calling it a nutritional enhancement, we call it a metabolic-based enhancement. And for purposes of government funding, nutrition and diet people kind of roll their eyes when they hear those words, like we've done the diet thing before. But really, what we are developing are kind of first in human molecules. It's actually almost appropriate to label them, even though when you consume them, they break down to bioidentical ketone molecules in the blood. But because they're sort of new entities that are formed, and we have no idea of what their therapeutic or performance enhancing properties are, and it's almost a safe thing to do to label them as kind of a drug at first, until we do the appropriate safety studies to show that you can feed this for the entire lifespan of an animal in even high concentrations, and that animal the females can become pregnant and give birth to offspring who are perfectly normal, maybe even enhanced in some way. So we are kind of doing those studies right now, the long-term safety studies, where we feed a very high dose for a lengthy period of time and do what we call an organ harvest. And we look at all the organs, we look at the kidneys, like what effect does this have on the kidneys, the mineral load even. What effect does this have? Does it stress the liver if it needs to break down these ketones? If it's not normally found in what they're eating and what humans are eating, is it stressing the liver? And we know things that are in nature can be extremely stressful to the liver. Plant-based products can be extremely liver toxic. Alcohol can be extremely liver toxic. Certain types of fats, sugar, fructose, for example, can contribute to what's known as non-alcoholic fatty liver disease, and it could be almost deadly to the liver if it's consumed, in excess amounts. It's almost like a protracted suicide. So we believe that nutrition is a very powerful metabolic therapy, and it needs to be appreciated, and it needs to be you need to respect it, because it can really influence a person's health in ways that we're just starting to find out.
Anecdotal study with me, my aunt was with Prove It doing like the MLM kind of thing, and she told me about it. I was like, I'll try it out. And the first time I tried the ketone salt, I was like, whoa. It was bad. I had a very acute sense of awareness, and I work outdoors, so I can kind of walk and I'm okay. But I was like, wow, that was really profound to just take this supplement and have such an acute awareness. And I take one program I work. I'll go down to the water source and carry up 100-pound jugs, and I hadn't eaten in like 24 hours, and I did that, and my muscles weren't even fatigued at all, and I was just it was incredible. So there's definitely huge potential that definitely needs to be understanding. So I appreciate the work you're doing to actually understand this. And
thanks for sharing that story.
But
I do get quite a few now that these ketone supplements are on the market. I get a wide variety of feedback from people taking them, from caretakers to Parkinson's disease patients, caretakers to Alzheimer's patients who their loved one is responding, is more animated, is talking, and some of them send me videos of them before and after, which is kind of really convincing.
Yeah.
And then I do get these emails from parents that have kids that are using the ketogenic diet, and by adding ketone supplementation, they can further improve their ketone levels, and it's something like that's semi-sweet and kind of like a dessert to them, so the kids really kind of appreciate it, and they have better control over their seizures.
Yeah.
And even because we deal with different types of rare diseases, some of the parents from kids that have what's known as glucose transporter type 1 deficiency syndrome have contacted me, and in one case, maybe two cases in particular, it literally like woke up the child, and the child began, to walk around.
Wow.
And they have big problems with energy because their bodies really can't use glucose very efficiently to the brain and to other areas. And then there was McArdle's disease, or glycogen synthase storage disease type 3. It's kind of a rare disease, and a lady sent me some video of her child like walking down her driveway and back after following the ketogenic diet and then supplementing it with ketones. So just a few examples of the feedback that I get on a daily basis of people, not only incorporating ketogenic nutrition, but or incorporating the ketone supplementation. So, we want to jump into clinical trials as soon as possible, but at the same time, we know I want to be extremely cautious and doing as much safety data as possible. And also with the esters, because they are kind of synthesized entity and in a way not natural, because they have an ester bond that's technically not found in nature. We want to study them as much as possible so we have a sufficient amount of data for what's known as the FDA generally recognized as safe category, or FDA GRAS category. And that involves putting together a complete application, that's hundreds of pages to the FDA, and just to show them that the safety studies have been done, and even a few pilot human studies, pharmacokinetic studies at high dosing levels.
So are these products that are currently out potentially unsafe, or they've been safety tested? Or?
I would say, so the salts kind of fall into a fuzzy category, because one could say that, if you're eating meat from an animal that's fasted in ketosis, there's a certain level of beta-hydroxybutyrate there.
Right.
And then obviously the meat has minerals in it.
Yeah.
And essentially that's what a ketone salt is. It's like ketones and minerals, whereas a ketone ester is like a strong ester bond of 1,3-butanediol, which is not found in mammals. Actually, it is found in some plants, in like a cayenne pepper in small amounts, and it's actually used. And 1,3-butanediol as a precursor to make a ketone ester, it has a little bit of a leeway because it's already FDA GRAS approved as a humectant, which is something added to different food products to keep it moist.
Yeah.
And also as a food preservative. They put it in things like sausage casings, and it's also widely used in cosmetics. 1,3-butanediol is, but even for human consumption. But the consumption is like at a small level. Right. So when you take 1,3-butanediol and make a ketone ester from it, you're consuming it in large quantities.
Yeah. And
the biochemistry has been sufficiently worked out, so we know it breaks down completely to 1,3-butanediol to beta-hydroxybutyrate.
Yeah.
But that involves liver metabolism of the same metabolic liver enzymes as alcohol. So alcohol dehydrogenase, and there's about 3 different enzymatic systems that are involved in converting the 1,3-butanediol to beta-hydroxybutyrate, and that can put stress on the liver. So we want to pay particular attention to look at doing studies that are really high dose feeding chronically, because we know that you put something on the market and you're going to have people out there that are consuming very large amounts of it. But you could say that with anything. Like Tylenol is deadly, to your liver. Caffeine, if you drink too many Red Bulls, if you take many products on the shelf, Vivarin or stimulant pills are being sold that are, let's keep this in perspective, far more dangerous than the ketone products out there. So we think that they are relatively safe, but because of the implications for their use, which is athletic performance, we know that people could be consuming very high amounts of it. The same thing happened with creatine, right? We thought it was dangerous to the kidneys and things like that, and it went back and forth. So now it's kind of widely accepted that it's safe, that even if you're on creatine, you're probably better off if you get a head injury. It can aid in that, and there's so many benefits. There was an article on creatine and cancer, that it could potentially prevent cancer. So creatine's an excellent molecule, and I think has a lot of potential as an energetic substrate. And I would say ketones are like the creatine of endurance performance. Right. So it's like, as ketones are hitting the market now, I think it'll be the next creatine, but for endurance performance, stamina, and even cognitive performance.
There's a few questions rolling around my head. I'm sure we're kind of coming up on time soon, but I did want to ask you one, which it's very related to what we're talking about. That kind of stood out to me. I don't know what you meant by it, but I think it was in Tim Ferriss's podcast, Dr. Ranja Patrick, you mentioned exogenous ketones being like a fourth macronutrient, or ketones being a fourth. Is that, can you explain what you meant by that?
Sure.
It's kind of a personal question, I guess, to clear that up.
So a macronutrient would be classically as carbohydrates, proteins, and fats.
Right.
And these are things that are found in our food supply. Ketones are kind of found in our food supply too, if an animal is in ketosis, but not. They are a natural endogenous metabolite. So what we have now is the ability to make this natural endogenous metabolite in sufficient quantities as a salt, and it has a caloric content. So it is energy, caloric energy that the body can use, and that's very that's very unique. So ketones are made from fat oxidation. Fats in your body are long chain typically, and what your liver does is kind of like a wood chipper and breaks them down into smaller molecules. And what we've done with exogenous ketones is harness the ability to deliver these smaller molecules that are they're part of fat oxidation. And they have an energetic content. So, and I guess amino acids may fall in the same category, and I know in the United States is the only country in the world that doesn't recognize the caloric content of amino acids. So if you take free-form amino acids, I believe, I could be wrong, but I know the regulation was such, just 2 or 3 years ago, and I think it still stands. If you consume a couple tablespoons of free-form amino acids, you're taking in calories, but the FDA does not recognize that as a macronutrient. So it should be labeled as protein. And I think ketones should be labeled as fat. Now there are ketogenic amino acids, lysine and leucine, and they can form ketone bodies, but 90% or more is derived from the oxidation of fat. So you have essentially these water-soluble fat molecules that are synthesized from natural precursors. Like there's a variety of precursors found in nature where you can make these ketone salts. The chemistry is kind of simple, and we can consume them as a calorie-containing beverage, or they could be put into bars. They can be incorporated into food. And it's giving your body a source of energy that has been shown to be superior to glucose. And I think
Yeah.
it's fast burning. It's difficult for the ketones to convert back to fat, so
Yeah.
they are preferentially oxidized very efficiently for fuel. And I like to just the simple analogy of pulling up to a gas station and you have kind of regular or low octane, then you have high octane fuel. And the ketones would definitely be high octane fuel, because when they're metabolized in the mitochondria, and this is a lecture that I teach right after this. I teach reactive oxygen species, or redox biochemistry.
Yeah.
When substrates are oxidized and broken down and oxidized in the mitochondria, and ketones are metabolized sort of more or less exclusively in the mitochondria, you generate less superoxide anion, which comes from between complex 1 and complex 2 of the electron transport chain in the semi-ubiquinone site. And that spits out a free radical known as superoxide, and then that free radical can go on and become more reactive and cause tissue damage. It's also an important signaling molecule. But importantly, if you're oxidizing glucose, it's spitting out that free radical at a higher rate. And if you're oxidizing ketones, you have proportionally less superoxide production in proportion to the ATP that's generated. So there's less, and that superoxide could be like analogous to the exhaust pipe in your car, right?
Yeah.
So you're spitting out less carbon, less waste. So when you're oxidizing ketones, it's a cleaner burning fuel, and that enhancement of mitochondrial efficiency, you know, if it's achieved and sustained over the duration of a person's lifetime, we think that enhancing the bioenergetic capacity of cells will preserve genomic stability. And it's that preservation of the genome, the nuclear genome, that's really important for preventing age-related chronic diseases and preventing cancer.
Yeah.
And, you know, we're only as healthy as our mitochondria are. And healthy mitochondria are really the ultimate tumor suppressor. So if your liver stays very healthy and you enhance the metabolic activity of the liver, it's far less likely to for the normal cells to transform into tumor cells.
Yeah.
If you're hitting the liver with toxic agents like alcohol over and over, you're going to be damaging the mitochondria, and you're going to be, by impairing the energetic state of the cell, the DNA repair mechanisms are highly energy dependent. So if the ATP is not there to repair the DNA, then you can cause DNA mutations, which can kick on oncogenes, which cause the transformation of a normal cell to a cancerous cell. And these oncogenes upregulate glycolysis, and you have a sugar-burning, transformed, cell bunch that becomes a neoplasm, and becomes cancer. Yeah. So that's our view. Our lab kind of views cancer as a metabolic disease, and it undoubtedly is. But there's a couple other, forms of cancer that the root cause could be genetic, but they're kind of few and far between, and metabolism is also intimately linked in there. So, but as in general, the research that we do kind of approaches not only neurological diseases, but also cancer and other disorders as metabolic-based diseases, which means a metabolic-based therapy can be used to treat, and if followed long-term, is effective preventative agent.
Yeah, you just blew my mind. That's incredible. I appreciate you answering that. I look forward to the future of ketones and how those will be integrated into everyday diet. It sounds very profound how this simple, something that you're working on, this simple molecule can prevent cancer. It sounds like it has strong implications in anti-aging medicine, and I know there's all boards for that and everything, so I'm sure they'll be incredibly interested in all that. And we are coming up on time, so I did want to ask you a couple kind of more intimate, personal questions, if that's okay with you.
Mm-hmm.
You're a very interesting guy. I don't know where I heard this, but what was it? You fasted for about a week, and you dropped your blood glucose levels to a level that could cause a coma, be potentially fatal. So I don't want to go into that. Anyway, I wanted to ask you, what was the motivation for doing that, and where does that determination and drive to come to really understand this stuff? Because that's most people would say, I'm not going to risk my life to understand this, but you're like, well, I'll do this, and hey, I'm sitting with you, you're fine, you're you're one of the top researchers in the U.S., probably in the world, and it's, so I just want to
know about that.
well, well, in my eyes, I guess.
Far, but, maybe
okay.
on the very specific subject of ketones,
right.
I'm in with a bunch, yeah.
Yeah.
So, but I appreciate that. It's very kind words. If I think back to kind of what motivated me to get in this field of research, it was some of the seminal papers that were published in the early '60s and the '70s, and one of them was, the first author was Oliver Owen, who was a really interesting character, medical resident at the time at Harvard Medical School, and his mentor was George Cahill, who I did get to connect with early on in my academic career, and we had some discussions on the phone. He passed away a few years ago at a advanced age. He lived quite a long time, but he did a study at Harvard on divinity students and essentially fasted them for 40 days.
Right.
And he looked at, it was a very elegant study for that period of time where they did the AV difference. So essentially looking at blood going to the brain and coming away from the brain, and specifically kind of, identifying what the brain was eating, what metabolites were being oxidized and produced even. So he showed in a very elegant study that the brain has the metabolic flexibility to transition from using glucose, which is 100% glucose utilization in a fed state. After about 7 days to 10 days, 2/3 of the energy metabolism was now being derived from ketone bodies, beta-hydroxybutyrate and acetoacetate. Right. And other studies were done around that time, and then some military did some work with fasting, and so I read a pile of papers, and I realized, well, if they could do 40 days, and there was another study that was done in 60 days, I should easily be able to do a week, especially because I'm in a healthy state, and I kind of know how to do it, and I kind of, will take some mineral supplementation to avoid some of the pitfalls associated with fasting as far as the dips in energy. So when I did that, the first 2 or 3 days, I think the beginning of the third day was particularly tough for me. It's just like my body didn't want to go, but then I started to wake up. My brain definitely did go through a mild glucose withdrawal, but I was somewhat adapted to low carb already and a modified ketogenic diet, so I think I adapted a little bit better than others. But I had one bowl of soup every day, which was just a beef bouillon cube, and I think a little bit I was supplementing magnesium, and would put some sea salt in my water and drink it. And I cut back on my caffeine, but I still maintained like 1 or 2 cups of coffee per day, and some green tea even, so I was getting a little bit of caffeine in there. And after, I think on the seventh day, I had to give, I lectured at USF and another fitness symposium or workshop, and gave some lengthy lectures, and on the last day I also went to the gym, and I did deadlifts, at a moderate to high weight, and it didn't really, I probably could have got more reps if I was in a fed state and I was full, because I was a little bit, I could tell my energy reserves were a little bit down, and I would describe a 1 week of fasting as being a little bit numb. Like my brain was a little bit numb, everything was kind of numb, but at the same time my thinking was perfectly lucid, and I was still motivated to do, but I wouldn't want to do it too much more than that, and I definitely wouldn't. It's kind of silly to do some kind of strength movement after that, because you are compromised in some way, but I felt I stayed within the realm of my physical capabilities in doing that. And I think it's when you can do things like this, it gives you a lot of confidence, and you realize that in the past, when I would go half a day without food, or miss a meal, I would kind of panic. Oh man, I'm starving. No, you're not starving. You can go a week without fasting, and even in that case, you're fasted, but you're not starving. Starving would be a depletion, a severe depletion of essential nutrients that puts your body in a compromised state. And that can happen in some people in 1 week, but typically in a normal healthy person can easily go a week and not be in a state of quote unquote starvation.
Yeah. Thank you for sharing that. I did have one more question before we go. Your work, I'm just wondering how, we're right next to Moffitt Cancer Center, and I used to volunteer there, and I was really interested in nutrition, and my experience was with the nutrition department is they were feeding people Snickers bars and sodas and all this kind of stuff. And I wonder, your research, what kind of effect or what kind of change are you affecting in, say, other cancer centers, or maybe in this area or abroad or wherever it may be? Is it something that you research and it takes 20 years, or because of podcasts or because of other things, maybe more people hear about it and they start maybe changing their modalities in these centers? So can you speak on that a little bit?
Yeah, thanks for bringing that up, because we're really excited to be collaborating with Moffitt on a ketogenic diet study. And Professor Nagi Kumar is the lead director of the nutrition program in Moffitt, and she does nutrition, basic science research, and clinical research. Yeah. And one of my students, Andrew Kutnick, connected with her, and it was discovered that they were very interested in using the ketogenic diet as an adjuvant to the standard of care. Yeah. So in particular for brain tumors, for brain cancer. And we are working actively with Moffitt right now to develop a multi-institute study where we're using the ketogenic diet for grade 2 and grade 3, hopefully astrocytomas. Wow. And we do have really good enthusiasm and support from the Moffitt, including the director, Bill Dalton, who is a former CEO of Moffitt and also the CEO of M2Gen, the spin-off company of Moffitt, attended one of our meetings and kind of gave it his blessing, and he does. So it's really encouraging to know that the former CEO and CEO of the spin-off company of Moffitt is enthusiastic about nutrition-based approaches, and in particular the ketogenic diet. Yeah. So we are actively working with them, but it's a step-by-step process. So what we're doing now is we're writing a grant to the National Institute of Health or the National Cancer Center that will hopefully fund a large study, and this will be like a government-registered clinical trial. Right. And keep in mind too that the Institutional Review Board, or the IRB, associated with Moffitt and other institutes will not pass a standalone ketogenic diet therapy as something that could be implemented without standard of care. So our approach will be to enhance the existing efficacy of standard of care with the ketogenic diet. And what's going to make our trial unique and sort of cutting edge is that we're going to use a modified supplemented ketogenic diet. So participants will be on a ketogenic diet, but that ketogenic diet will be further enhanced with ketone supplementation. Yeah. And we're trying to figure out right now what would be the ideal ketone supplementation. We have a couple candidates, but we want to make sure the formula is palatable and it'll be well tolerated and it'll be highly effective. And we have a few candidates, and we're just screening out which one will work best.
That's great to hear. Also reassuring. I guess I had a different experience 6 years ago, but obviously I wasn't in the research realm. I was just kind of a volunteer and just a student. Like, how can I help? What do you guys have going on here? So that is great to hear. And I know I can't remember which podcast it was, but I remember you talked about people may have concerns fasting, muscle wasting and sarcopenia and all these different things. Yeah. But I know you did speak on that before, so I'll try to redirect people if they're interested in that. And we are definitely coming up on time. I know you have to get to you have a lot to do today. So I wanted to just ask you, how can people connect with you? You kind of talked about what you're working on in terms of research, but I know you have a podcast, maybe you're working on that. So how can people get in touch with you and see what you're working on?
I think probably the best thing to do would be go to, if they're interested in this area of science, ketonutrition.org is kind of a website that I just threw a bunch of links on. Yeah. And if you click on resources, There'll be ketogenic diet dietitians, clinical
Yeah.
trials, books, and that sort of thing. And then there's a link on there in academia.edu, which will open up all the publications that I have. And I sort of uploaded them on there so you can download them. Some of them are not open access, but they're still free. So I don't know how long the publishers will let me do that, but I've put books and publications on there that you could essentially download for free.
Yeah.
And when we do publish our articles, we do pay for the open access fee, which could be upward, $2,000 to $3,000 sometimes. So we try to do that and make it. Make our research out there accessible to the public, and I've been trying to do that with podcasts and things like that.
Yeah.
So I'm on Facebook, LinkedIn, and Twitter, so if you could follow me on those things. And about once or twice a week I publish something related to something new that has come out in this area of research. So I think those avenues are good ways to connect with me and follow what I'm doing.
Yeah, and on your website, you were talking about this, the financial kind of burdens of making this stuff available. People can donate directly to you, is that correct?
Yeah, that's right. I created a foundation account. So I should say that University of South Florida has a foundation.
Yeah.
And in that foundation, I created an account for a metabolic therapeutics account.
Right.
And it's a 501c3, and if you donate to it, it's 100% tax deductible, and 100% of those of that donation will go to our lab to advance the science and application of metabolic-based therapies. So if people are interested in donating, we really appreciate, no matter how big or small, any donations really help out. And I really like to stimulate and support our undergraduates in their research efforts so they can do undergraduate research projects. And hopefully my big motivation is to steer incoming students into a path of research or medicine, and where they incorporate these metabolic-based therapies.
I appreciate you coming on this show and just taking the time to talk with me. It's kind of embarrassing, but I'm a huge fan. And
thank you.
I'm sure I don't know if you have a
blushing.
fan base, but it's very humbling to have you come on and take your time. I know you've talked to people who have a lot bigger followings than I do, and hopefully I'll get to that point one day and get the word out about what you're doing, and do my best to do that. But I appreciate it.
I think you will. It's clear you're very passionate and skilled at what you're doing. So I wish you all the best, and let me know how else I can help you.
All right, thank you very much. I appreciate it. Thank you so much for joining us on this episode of the Modern Day Superhero Show. If you enjoyed it, don't forget to hit the subscribe button on iTunes, YouTube, Stitcher, or wherever else you may be listening to the show. If you've got a second, please leave a quick review on iTunes. And if you think someone else you know may benefit from the show, please take a second to share it with them. You can get in touch with me on Twitter at MDSuperhero and Facebook at Modern Day Superhero 1. Better yet, you can enter your best email at moderndaysuperhero.com or text keyword superhero to 38470, and I'll send you my free newsletter. On the site, you can download all other podcast episodes I have created, along with corresponding transcripts, and you can check out my blog and vlog there as well. Did you know that you can directly support the production costs of this show for as little as $1 a month? Not only that, direct sponsors are entitled to awesome additional benefits, such as ad-free shows, access to shows before they're released in iTunes, additional content, including blooper reels, and much more. For more information, check out moderndaysuperhero.com/crowdsponsor. Thank you again for listening to the show, and I hope you have a wonderful day.